Hello everyone, welcome back to the channel. Let's implement the router as well as the util package of our CoreUI module. Create a new folder, router, a new empty file. It's gonna be for the destination. Basically, we have defined the destinations and the available screens of our app under the Kotlin application. We have home screen, product details screen, the product search results screen, as well as the unauthorized or page 401. It's gonna be simply an enum because we don't have sealed class here. Let's call it destination. It should be codable and hashable. We need those types in order to save latest destination in our database to handle the app termination. Regardless, we're going to end up visiting the latest screen. It's going to give good user experience. For the first destination, it is home screen. The second destination is product detail screen. In the product detail screen, we need the product's ID of type int64. And for the rest, we have wishlist manager screen, product search results screen, and page 401. I need to override here the raw values for this home screen in order to be better representable while caching our latest visited screen. Let's override this home screen. The raw value, it's going to be presented like home screen. In case of products ID from the arguments. And this is basically the raw value of product detail screen if you want to cache, for example, this particular screen in the database. And let's add the product's ID. When we save this particular product detail screen under our database, it's going to be stored like product detail screen /and1, for example, referring to product's ID. Likewise, for the other cases, wishlist manager screen, product search results screen, and unauthorized screen. To make our life easier, I would like to add an optional initializer for this class in order to get from the raw value the related destination. If we pass, for example, to this initializer home screen, it's going to give us home screen here. The challenge here is the product detail screen. That's why we're going to handle this optional initializer. Let's add this initializer underneath the raw value. It's going to be public initializer, which is optional. We need the raw value, which is the other direction from raw value to the, that's going to give us, and should give us actually, the home screen case of type destination. Switch statements. Under the home screen and wishlist manager, product search, and unauthorized screen, nothing special. But for the product detail screen, we have this extra slash here under the route, if you will. We need to handle this. Therefore, we have to split this particular section by this separator if we have multiple sections. I'm going to store that under the array. Let's call it parts. Part refers to the parts of the route, omitting empty subsequence to false. And we have to access the first occurrence. In case of home screen, let's try to copy the same value in order not to make a typo. Home screen. For the default, we're going to do here null. For the other cases, wishlist manager, product search, and unauthorized, basically the same thing. Now let's handle the case product detail screen. From splitting this route, we will have the product detail screen and the rest of the sections or the parts. Now we need to retrieve the product ID. If the parts after this product detail screen equal to from string to integer 64, and we need to access the first one. Parts 0 stands for product detail screen, and parts 1, which is the ID, and we have to convert it to integer 64. In this case, self equal product detail screen, and we have to pass as an argument the product's ID. Otherwise, we will return null. And that's all for the constructor. I would like to define the private and public routes under this particular computed property. If it's not wishlist manager screen, it's public. Those are public routes. And that's all we have for the definition of destination. Now we need to implement the router, a simple view model, if you will. And for Swift, the view models are represented by observable objects. One simple and one state, which is the navigation stack. Let's annotate it with published. It is an array of type destination, and let's fill the initial array with home screen. It should have the home screen as an initial value. I'm gonna add here a convenient function to access the current destination. the last value under the array by doing navigation stack and last, and it should be nullable. That's why we have to add here null. Next, we're going to define the function to navigate to the next destination. And I would like to make it the same thing that we have done under Kotlin application. A callback function that's going to be triggered or to be executed before navigating. It is an escaping function. You have to pass here destination without any return type. Let's make it optional, this parameter. First of all, we're going to make sure that we're not going to navigate to the same destination by doing guard, navigation stack, and last route, else return, or to make an error return, nothing to do here. Next, we're going to navigate, or to call the onNavigate, whatever we want to do here, and to pass the route as an argument. And we're going to push or to append the destination to the list of the destinations. This will avoid duplicate destinations. Now we have to implement the navigate back. Now we need to make sure that the stack is not empty by doing navigation stack and empty. If it's not empty, we're going to proceed by calling onNavigate. Let's use it. Let's rename it to onNavigate back. I'm going to remove the last destination, or we're going to remove the last item from the stack. Now let's handle the util package under CoreUI. I'm going to create here a new folder. Let's call it util. I'm going to provide the constants that we're going to use in this particular project. It's going to be a simple structure defining the current destination key and load interval and whatnot. So we don't have to hard code this, which is a good thing. If you do remember, we have defined the string avatar. Let's make the Swift version for string avatar under new file. Let's call it helper. First, we're going to trim this particular string. Let's take, for example, this particular string. We're going to separate or to get the parts by the white spaces. Therefore, we're going to use components separated by white spaces. And we have to filter if we don't have any empty space after the white space, $sign and 0, and we should filter by non-empty values. All right. Now we have the parts, for example, created by Butter, and we have the parts under the array. We need to switch is greater than 2 elements, or the amount of the array, or the items under the array are more than 2 elements. We need to do here, we're going just to take the last occurrence. Let's store first of all the first result. Let's take the first character, of course, and we have to do it as uppercase, if you will. If it's not, it's gonna be an empty string. The same thing for the other or the second part. Let's say, for example, C and B, second one, and first character uppercase, otherwise empty string. I'm going to add them to each other. All right, by doing first initial plus second initial. Case 1, what we have to do here is we will return this particular string, which is parts, going to return 2 characters from the string and to switch it to uppercase or to convert it to uppercase. The default, which is basically empty string. That's the implementation of a string avatar. If you do remember, under the Kotlin version, we have implemented the media query, enon. We have small, medium, large, and extra large. The same thing that we have done under Kotlin. And I would like to define or to add a useful extension function on CG size in order to get the screen size according to the particular or the current size. It should give us screen size. If the width is more than 840, we are on extra large. If it's between 680 and 840, we are on large screen. If it is 480 or between 480 and 600, or per se 599, I guess, we are under medium screen. Default value, it's gonna be small screen. That's pretty much it for the media query. In order to make CoreUI bundle accessible from outside the module, I'm gonna create here a file under util CoreUI bundle. Simply an extension function over bundle. I'm going to expose the bundle module. Let's name it CoreUI bundle, which is bundle and module. Since our application is going to use the infinite scroll, we need to define or implement this functionality under the CoreUI. Let's create a file and call it load more trigger. In Jetpack Compose, it was very easy to implement this kind of feature, but under Swift, we have to do this a little bit differently. It's gonna be basically a view. Now what we have to do, we need to track if the trigger has already fired or not in order to prevent multiple calls. Let's add here an internal state and a callback function or a closure to execute when the bottom is reached. And we have defined actually the buffer in the Kotlin version. We're going to do here the same thing. Let's call it, for example, threshold. It's gonna be an extra margin before the actual bottom to trigger. Let's define the initializer for load more trigger. For the threshold, I'm gonna do here as a default value 50. Next, we're going to read the position of the view in global coordinates by using geometry reader. I'm going to add just a color, clear color, if you will, an invisible element to track scroll position. I'm going to send scroll position using preference key. Now we have to create the preference key used to communicate bottom position across the view tree. Let's call it bottom reached preference key. Let's set the default position. If nothing is set, it's going to be of type cgfloat. It's going to have a value of 0. The structure is going to be of type preference key. It is a named value produced by a view, and we have to override the method reduce. In our case, we're going to always take the latest value and ignore the previous ones. It's going to complain about safety or thread safety check. Let's add here main actor. Let's add here pre-concurrency before preference key. Now our bottom reached preference key is thread safe. Let's provide here the key, which is bottom key, preference key, and self. For the value, we're going to assign here the top Y position of this marker. And frame, we have to access the minimum Y position. Basically, it's the top Y position of the marker. Next, we have to specify the line as a marker by doing something small, for example, the height of 1. And we have to do it like a frame, for example. Now we have to call on preference change. Let's pass here the bottom reached preference key and self. This is going to react basically to the position changes. Now let's get the screen height and store it under value screen height equal UI screen height or UI screen main bounds and height. Now we have to check if the marker is within the threshold below screen and hasn't triggered yet. And the marker basically is this minimum Y position by the frame of one single line. Now it should be below the screen height plus the threshold. Maybe we don't want that the position to be flush with the bottom of the screen. And of course, it shouldn't be triggered. We have to change the value of has been triggered. This basically will prevent repeated firing. And we have to call on trigger. I would like to add a useful function. It's going to be used externally to reset the trigger state after loading finishes. A parameter of type binding that's going to change basically the value. We have to observe the reset binding changes by doing self or just directly on change of the value. Here is reset value, which is the binding, and wrapped value. Let's add here parameter new value. Next, we have to check if the value is true or the new value is true. Change the value of has triggered to false. Allow triggering again, the triggering mechanism to fire again. And we have to reset the binding back to false asynchronously by doing dispatch queue main async reset and wrapped value equal false. And that's all we have for the mechanism of load more trigger or the infinite scroll. It requires a little bit of, it's a little bit tricky, but the main key here is we have to specify the marker whenever we are scrolling the page, and we have to keep track of this position, and we have to check if we have reached the minimum or the bottom of the screen plus the threshold. Before the threshold, basically, we have to trigger. And I think that's pretty much it for today's video. For the next tutorial, we will start implementing the components. I hope you have learned something new. See you in the next one, and happy coding!